Welcome to the lesson for 8.1 day 2. This is the second installment of sequences and series. We're going to kick things off by simplifying the ratio of factorials, and let's look at example 1 to begin that. Okay, looking at example 1, we've got 25 factorial divided by 23 factorial. So recall that the factorial means that you start with whatever quantity you're starting with, and then you multiply by all of the whole numbers that are one less than the prior term. And so it just continues on and on until you get down to 1. So we can write out the factorial for as many terms as you want, but when we're canceling this, I don't want to write down all of those numbers, okay? And so my denominator here is 23 factorial. So notice that that's going to be 23 times 22 times 21 times 20. And I'm going to stop the factorial there instead of continuing to write the pattern. Normally, I wouldn't even write this many terms out, but I'm just trying to show you how the factorial behaves. Well, 20 factorial is going to cancel with 20 factorial because that's just the shorthanded way, remember, of saying 20 times 19, 18, 17, all the way down to 3 times 2 times 1. And then notice that the 21s cancel, the 22s cancel, and the 23s cancel. So I could have started right there with canceling the 23 factorial on both, and then I would just have simply 25 times 24 in the numerator position, and that would be 600. Okay, so common factors of the factorial symbol divide out, and the quotient is 1. Let's look at example B. So notice that I have 10 factorial. So I'm going to start with that one. I'm going to do 10 times 9 times 8 times 7 times 6 factorial because I can see that I have a 6 factorial in the denominator. And so the factorials then, the 6 factorials divide out. Now notice in the numerator, I have the 3 factorial. Well, I'm going to leave that alone. But my denominator of 4 factorial would be 4 times 3 factorial. So then the 3 factorials would also divide out. Okay, and then all we have left is 10 times 9 times 8 times 7 divided by 4, and the math for that works out to be 1260. Okay, so common factors that are on a factorial divide out. Now, what happens when we have a polynomial? Well, 2n plus 2 quantity to the on a factorial is going to equal 2n plus 2, because that's your starting point, and then 1 less than that would be 2n plus 1, and then 1 less than that would be 2n, and then I'm going to stop the factorial there, because notice that I have the quantity of 2n factorial in the denominator. So then that divides out. Oops, that divides out. And then we're simply left with the product of 2n plus 2 and 2n plus 1. Well, if we multiply those together, we get 4n squared plus, what is that, 6n plus 2. So a polynomial behaves the same in that you're just subtracting 1 from each term, as you go down the line. Looking at example D, we have quantity 2n minus 2 factorial divided by quantity 2n minus 4 on the factorial. Okay, so my numerator is going to be, I'm going to start with 2n minus 2, and then my next one would be 2n minus 3, and then 2n minus 4 quantity factorial, and then that divides out then with the denominator's factorial. All right, and then my product here is going to be 4n squared minus 10n plus 6 for my final answer there. Okay, so the trick with the factorials is remember that this is like your starting number or quantity, and then each subsequent term is 1 less than that. And you just keep going forever, or you stop and then put your factorial sign back in. The next piece is how to add up the terms of a sequence. There is a convenient notation for the sum of the terms of finite sequences, and this is called summation notation or sigma notation. It's the same thing, And it's because it involves the use of the upper case Greek letter sigma, which is that sign right there. I'm sure that you've seen that before. The sum, so formally the definition is the sum of the first n terms of a sequence is represented by this symbol here. Okay, and then this simply means that we're just going to add up all of the terms in the pattern. Now there's some new notation here, and we want to make sure that you understand all of the pieces here. I is said to be the index of summation. Okay, that letter is usually I, but it can be other letters. It can be N or it could be K. Those are kind of the other typical ones. The value that is above the sigma, this is the upper limit of summation. So that's like the ending number. And then the number down here at the bottom is the lower limit of summation. That's the beginning number. Okay, so technically this is where you begin, that term number, and then this is the term number that you end with. Okay, so let's find the sum. So let's take a look at example 2 here. So we're going to find the sum of quantity k plus 1 times k minus 3 over the interval of 2 to 5. Okay, so what this is telling us is we are going to write it out, and we're going to begin by letting k equals 2. So we're going to do 2 plus 1 times 2 minus 3. Okay, and then we're going to add to that the next term. Well, we start with term number 2, and then we end with term number 5. All right, and so my next term then is going to be 3, because 1 more than 2 is 3. So 3 plus 1 times 3 minus 3. And then my next one is when k is 4. So 4 plus 1 times 4 minus 3. And then lastly, with the fifth, 5 plus 1 times 5 minus 3. And you can see what a real pain this is for the more terms that you have to write out. Okay, so notice that I get 3 here and -1, so I get -3 from the first one. And then I get 4 times 0, so that's just 0. Okay, and then my next one, that's 1, so then I get 5. And then 6 times 2 is 12. And adding those together, I get a sum then of 14. Okay, now that's a real pain. The second way is to use the graphing calculator. And again, I've shown you over here basically the screenshots. The old operating system, again, you don't really need to worry about that unless you're on the older calculator. On the newer one, you just go to math and then you go to 0, and I'll show you that in just a second. Or go to alpha and then window, and then its number 2 is the summation command. So I'm going to flip over to my calculator and show you that. Okay, so in math, if we come down to 0 or up to 0, that gives you the summation command. I don't use that one that much. I prefer alpha and then the window, and then its number 2 is that command. Okay, so what you have to do is you have to put in your variable, you have to tell the calculator where to start and where to end, and then you have to put in the explicit formula. So we've got n plus 1, and then we've got, what was it, n minus 3. And hit enter, and voila, 14, and that's exactly what we had done by hand. So just be aware that, you can write it out by hand, but we also want you to know how to use your calculator. So again, it's alpha window, and then number 2, or math and 0. Looking at example 3, use sigma notation to write the sum. Okay, so that means that we're going to write it, with this new way, and then use a graphing calculator to find the sum. So what we have to do then is we have to figure out the explicit formula. And that's what we did yesterday. Okay, so again, n is the position, and then a sub n is the term's value. So here we go with term number 1, term number 2, 3, 4, 5, and 6. So right away, hopefully you can see the numerator is the factorial pattern. Immediately I can see that the numerator is n factorial. And again, that's because we, wrote out that list already, and we should recognize that. Now look at the denominator. That also is a very straightforward pattern, and those are all powers of 2. So 2 to the n power gives you the denominator. So that's a really easy, explicit formula to generate. Now I need to tell the reader, where are we beginning? So we're beginning with the first term, so n equals 1, and then we're ending with 6. And you have to have all of these pieces on here, otherwise it's not right. Okay, that's the first part, and then the second part is to use the graphing calculator and find the sum. All right, so we're going to go and grab our sum command. And we went from 1 to 6. Okay, and then my numerator was n factorial. And then the denominator was 2 to the n power. Alrighty, and that's it. And then there we go, 73/4. If your calculator did not give it to you as a fraction, remember you can always go to math, and then fraction and decimal, are option 1 and 2. So if I wanted the decimal, 18.25. Okay, so the sum of this, is 73/4. Okay, easy peasy when you can do it on the calculator. There are properties that comes with the summation sign or the summation command. And so these properties, these are basically shortcuts. And this does become important when we're doing our math, basically in calc, when you're looking at the area under the curve and you're starting with Riemann sums. This is going to be important at that point. Okay, so we want you to see it at least one time now. Okay, looking at number 1, it says that if you take the sum of 1 to n of c, that's equal to c times n, where c is a constant. Well, that's a little bit hard on the eyes, so let's look at a number example. If I told you starting at 1 and going to 4, if we were summing 5, that's what this is saying here, that this is a constant. Well, this is equal to simply doing whatever that is, whatever that quantity is, times the upper limit of summation. That's what that shortcut is telling you. Because you're taking 5, if we were to write it out, well, there's the first term and the second and the third and the fourth, and then we're adding those together. So that's what that is telling you there. It's a little bit easier to see when you look at a number example. Okay, the next one is that if you take the sum from I to n of a constant times a pattern, an explicit formula, that you can actually factor the constant off and then simply find the product of that with the sum. All right, so what exactly does that mean? Well, here's the example. So let's just say that I have the sum of, let's do 1 to 10 of, I don't know, like 5 halves on, let's do the squaring pattern, I squared. Okay, what this is telling you here is that you can simply do the sum for the I squared part from 1 to 10. And then once you get that answer, then you simply multiply that answer, that sum, with 5 halves. That's what this rule is telling you here. The next two I think are pretty straightforward. The sum of a sum is the same as doing the sum of each individual term. And then the same thing holds true for a difference. There are numerous applications that involve summing the terms for an infinite sequence. So remember that in an infinite sequence, we would start at, whatever number it is, and then we wouldn't end. So it would just be like continuing the pattern, and we would denote that with like a dot, dot, dot. These kinds of sums are called infinite series, or just a series, whenever you see that dot, 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 or the upper limit is infinity. The definition then of these is that the sum of the first n terms of a sequence is called a finite series, or the partial sum of the sequence is denoted by the following. So here, finite means that we've got a beginning and an ending value. Okay, the infinite, we've got a beginning, but we don't have an ending, so we either use the infinity symbol here, or if we were listing out the terms, it would just be a dot, dot, dot. So just note that you can have a finite series, or you can have an infinite series. And again, the finite is sometimes said to be a partial sum. And so you want to make sure that you understand that the partial sum means that you're starting at, whatever point and that you're ending at whatever point. Looking to example 4, it says find the fourth partial sum of this quantity. So we've got an infinite series here with the notation, but then they tell you to find the fourth partial. So what that means then is you're replacing the infinity with the number 4. We're starting at 1 and we're going to 4. Okay, well, let's go ahead and let's do it by hand just for fun. All right, so notice that I have this constant times the negative 1/4 quantity to the n. So I'm going to use my shortcut. So I'm going to do my 8, and then I'm going to find the sum of my terms and then multiply the 8 up with the sum. So I'm going to have negative 1/4 to the first power. And then I'm going to have negative 1/4 to the second power, and then the third, and then the fourth. So again, once I find that sum, then I'm going to multiply that with the 8. Okay, so this is going to give me 8 times. So I'm going to have negative 1/4, and then I'm going to have positive 1/16. I have negative 1/64, and then I'm going to have positive 1/256. And of course, at this point, we're going to need our calculator. And so when we do that, we're going to get negative 51/32. Okay, and then again, we can always do this on the calculator as well. Let's just confirm our work. Okay, so grab your summation command. All right, so we're starting at n from 1 to 4. Okay, and then we had 8 times the quantity, negative 1/4 to the n power. And let's see how we did. Okay, we have no idea what that is. Let's go to the fraction version, and voila. Now let's see what we get if we factor the 8 off, because I just want to show you that we'll get the same thing. So we're going to start with 8, and then we're going to do our summation part. So then n, we're going to start at 1 and go to 4. Okay, now this time be mindful, don't put the 8 in because we already factored it off. So we're going to have negative 1/4 quantity to the n power, and voila, same thing. So, okay, that concludes the lesson for today. Kind of a little bit easier after what we started off with yesterday. So again, just make sure that you understand what this partial sum means, what the summation notation means. Also, again, how to work on those factorials. Be sure to get your assignment completed and submitted to Canvas, and let me know if you have any questions.